Back in section 1.2, we talked about the difference between a designed experiment and an observational study. If you'll recall, in an observational study, we obtain information from a sample or a population, either one, but usually a sample, but we don't do anything to manipulate any of the variables. So we don't manipulate explanatory variables or response variables, either one. But in a designed experiment, remember, we change the values of explanatory variables to try to see what the effect that causes on the response variable. So anyway, back in section 1.2, we looked at the difference between an observational study and a design experiment, and then we focused on the different types of observational studies. So if you'll remember, we talked about cross-sectional studies, we talked about cohort studies, and so on. Well, now we're going to focus on experiments and the different types of experiments. So that's the notion of section 1.6. So we defined experiments previously, but just as a quick review here, an experiment is a controlled study conducted to determine the effect varying one or more explanatory variables or factors has on a response variable. Notice that the author just threw in another term here, factors. So if we vary the factors, we want to see what the effect is on the response variable. So factors is just another term for explanatory variables. They mean the same thing. Any combination of the values of the factors is called a treatment. So however we manipulate the explanatory variables or the factors, that's going to be a treatment in our experiment. So in an experiment, we're going to have experimental units or subjects. So an experimental unit or a subject is a person, object, or item upon which a treatment is applied. So the individuals that we are treating, whether they're people, whether there's plants, whether they're some other kind of object, those are the experimental units or the subjects of our experiment. A control group serves as a baseline treatment that can be used to compare to other treatments. So always in an experiment, we have at least one treatment group. So a treatment group is a group who is receiving an actual treatment. The variables are being manipulated, or there are the factors that are being manipulated. A control group is a group where the factors are not being manipulated. So we can compare the treatment group against the control group to see if there's any kind of difference. So again, the control group is kind of like our baseline that we're going to be measuring against. So when we have people involved, oftentimes if an individual knows that they're in the control group instead of the treatment group or vice versa, that can be a problem. Therefore, we typically use placebos whenever we are dealing with people. Now, obviously, if we're dealing with plants or animals or something like that, we don't have to have placebos. But if we're dealing with people, we will generally have placebos that are used for the individuals who are in the control group. So now what's a placebo? Well, a placebo is an innocuous medication that looks, tastes, and smells like the experimental medication. So typically we're talking about medical kinds of research whenever we talk about using a placebo. So that the individuals in the control group don't know they're in the control group because they're receiving a fake medication that looks, tastes, and smells like the real medication. So no one knows who's in the treatment group versus who's in the control group because, human nature, thinking that you're getting a treatment can actually affect the values of the response variable. So just as a quick example of that, suppose I have a new medication that I want to test. And the purpose of this medication, I think, is to reduce the severity of migraine headaches. Well, just because someone thinks they take a medication, it's possible that psychologically it could help them deal with the pain that they're having with the migraine headaches. Even though they may not be receiving actual medication, they may be able to cope with the pain better, and so as a result, they may feel better. And it doesn't have to be pain. It could be things like blood pressure or cholesterol levels. Anytime someone thinks they are receiving a treatment, it can help them cope, and that can affect the results of the response variable. So therefore, we try to control that by the use of a placebo. So again, the idea is that we don't want the individuals, again, when we're dealing with people, to know if they're in the treatment group or in the control group, because again, that can affect the results. So blinding refers to non-disclosure of the treatment an experimental unit is receiving. So in other words, the person doesn't know if they're receiving a treatment of a placebo or a treatment of the actual medication. Now there's two types of blinding. There are single blind experiments and there are double blind experiments. A single blind experiment means that the subject, the experimental unit, doesn't know which treatment they are receiving. So the subject, the experimental unit, doesn't know if they're getting the placebo or they're receiving an actual treatment. That's single blind. In a double blind experiment, the experimental unit or the subject doesn't know which treatment they are receiving, and neither does the researcher that's interacting with the experimental units or subjects. So whoever the individual is who is actually doling out the medications or the placebos, that individual doesn't know who's getting which kind of treatment. There is another party who does know who's getting the placebos and who's getting the actual treatment, but there's this intermediate person who is interacting with the subjects who doesn't know either. Now, the purpose of double blind is it's just a level of security. If I'm doing a single blind experiment and I know that I'm giving someone a placebo, I might inadvertently communicate that and let them know that they're not receiving the real treatment. Now, I wouldn't probably do that on purpose, but just by my body language or something like that, I could indicate it. So double blind's better because if I don't know if you're getting a placebo or the real medication, then I can't very well let the cat out of the bag for you. Let's next look at the steps in designing an experiment. So the steps in designing an experiment are very much like the process of statistics, or really it's kind of an experimental design in general. So to design an experiment means to describe the overall plan in conducting the experiment. So if you're going to conduct an experiment, you need to lay out what your process is going to be. It has to be well thought out. You have to strategize to think about, what am I going to do in particular circumstances? How am I going to go about obtaining my control group and my treatment group or groups, and so on. So the first step. Step one, we have to identify the problem to be solved. In other words, what's the objective? What is it that we're trying to do in our experiment? What is it that we're trying to learn? So that's step one. Figure out the purpose. Identify the problem that you're trying to solve. So in my example, I said I have got this new medication and I want to know if it effectively treats the severity of migraines. In other words, does my medication make migraines less severe than if someone didn't have this medication? That would be my objective. Is the medication effective? Step two, I have to determine the factors. Now, what exactly does that mean? Now, factors, again, if you will recall, is another word for the explanatory variables. So what are the explanatory variables that might affect the response variable? So in my example, the response variable is the level of pain from the migraines. So what might affect the level of pain from migraines? What are the factors that could contribute to either worse or lesser migraines? Well, in addition to the medication that I am testing, there are other things that can affect whether a person has a migraine and how severe it might be. So there are things like family history. Perhaps if one's parents have migraines, then the child might be more apt to have migraines that either are more or less severe, and so on. Things like diet might affect the severity of migraines. Things like exercise habits might affect the severity of migraines. Things like season of the year and allergy levels, those kinds of things might affect severity of migraines, and so on. So again, in step 2, we want to try to form a list of all of the possible explanatory variables or all of the factors that might affect the response variable, in addition to whatever it is we're actually testing. Step 3, determine the number of experimental units. How many individuals do we need in our experiment? Now, typically, if we're doing a medical study, we start with a relatively small number of individuals. And then if it looks good, then we might expand that to a larger group. So for example, my medication might do a really good job at reducing the severity of migraines, but there could also be really horrible consequences, like maybe the medication does damage to the kidneys or to the liver or something like that. So we don't want to give this medication to thousands of people without knowing maybe what the potential side effects could be. So we usually start with a relatively small number when we're dealing with people and medical research. And then again, if we don't see any major side effects in the small group, then we might expand that to a larger group. So again, we always have to worry about how many individuals are we going to be including in our research. Now, step 4, determine the level of each factor. How are we going to deal with the different explanatory variables? One of two things. We can either control the explanatory variable or we can randomize the explanatory variable. So what in the world do I mean by that? Like if I'm testing my medication, I can control who's getting the medication and who's not getting the medication, and I can control how much medication they're receiving. So some individuals might get a placebo, so they're getting none of the medication. Some individuals might get 100 milligrams of medication per day. Some individuals might get 200 milligrams of medication per day. And some individuals might get, say, 400 milligrams of the medication per day. So I have 3 different treatment groups plus the control group, so 4 groups of individuals. And I'm controlling the factor being the amount of medication. So again, that's the explanatory variable. Now, I may also be able to control some of the other explanatory variables as well, some of the other factors. So for example, I might be able to control like water intake, how much water the people being studied get to drink in a day, or what their diets are, and so on. I might be able to control those things as well, but that would require a pretty sophisticated experiment. So again, control. There are 2 ways to control the factors. One, we can set the level of a factor at one value throughout the experiment if you're not interested in its effect on the response variable. Or 2, we can set the level of a factor at various levels if you are interested in its effect on the response variable. The combination of the levels of all varied factors constitute the treatment in the experiment. So again, something like water, I can just have everyone gets the same amount of water, for example. So I'm controlling that by just giving a single value to everybody. Or I can do different levels like I'm talking about with the medication, 100 milligrams, 200 milligrams, 400 milligrams. Or I may just give everybody 100 milligrams, in which case I'm setting the factor to be the same for everybody. Now, there are some variables that we're not going to be able to completely control. So things like diet may not be controllable. Things like family history may not be controllable, and so on. So to deal with that, we randomize. We randomly assign the experimental units to the treatment groups. So in other words, I'm randomly going to assign which individual goes in the placebo group, which individual goes in the 100 milligram treatment group, which individuals go in the 200 milligram treatment group, and which individuals go in the 400 milligram treatment group. I randomly assign in order to try to keep a little bit of control. It's not complete control because it's random, but by randomly assigning who goes in which group, I'm probably not going to end up with one of those factors that ends up maybe affecting the response variable, because we're going to have some in each of the groups, most likely. Because it is difficult, if not impossible, to identify all factors in an experiment, randomly assigning experimental units to treatment groups mutes the effect of variation attributable to factors not controlled. So if there are variables that we can't control, explanatory variables I mean, then by randomly assigning who goes in which group, that kind of mutes any effect that that variable might have on the outcome. So that was step 4. Step 5, conduct the experiment. So once we have everything laid out, we actually conduct the experiment. Now, what does that mean? So we actually, over a time period, give people the placebo, give people the 100 milligrams, the 200 milligrams, the 400 milligrams, and we control all of the other things that we've talked about. So basically, we execute our plan. Now, replication occurs when each treatment is applied to more than one experimental unit. So by using multiple individuals, we are repeating the treatment to multiple individuals. Using more than one experimental unit for each treatment ensures the effect of a treatment is not due to some characteristic of a single experimental unit. So again, by using replication and giving the treatment to multiple individuals, we're not ending up with flukes that might occur for one individual that doesn't occur for other individuals. It's a good idea to assign an equal number of experimental units to each group. So for example, if I'm going to have 100 individuals in my study for my migraine medication, then I would probably have 25 in the placebo group, 25 in the 100 milligram group, 25 in the 200 milligram group, and 25 in the 400 milligram group. Replication can also refer to, if I start with a small group of individuals and I achieve a particular result, then if I expand that to a larger group, can I replicate the findings from my smaller group? So replication can also deal with that. B, collect and process the data. So I've administered my medication and placebos over time. I've had the patients keep track of how often they've had migraines and how severe they were and so on. So I've obtained the data. Now I'm going to process that and analyze it. So measure the value of the response variable for each replication, for each individual, then organize the results. The idea is that the value of the response variable for each treatment group is the same before the experiment because of randomization. Then any difference in the value of the response variable among the different treatment groups is a result of the difference in the level of the treatment. So again, basically when we start with the 4 groups in my example, those 4 groups are equal, so to speak. So equal in terms of all of the explanatory variables. So the only difference is going to be the level of medication that they're receiving. So if we find out that there is a difference in the severity of their migraines over the time of our study, then the medication would be what we think is causing the differences in the severity of migraines. Step 6, we're going to perform inference. We're going to test our claim. So if our claim is that the medication is going to reduce the severity of migraines, we're going to test that statistically. So again, when we get to around chapters 9 through 13, we'll be talking about inferential statistics at that point. So just as a reminder, inferential statistics is the process in which we make generalizations about a population based on the results we found in our sample. So if we had a sample of 100 individuals and it appears that our medication's effective in treating migraines for those 100, then if we expand that and say we believe that's going to be true for the population in general, we are making an inference. And so again, later on, we'll talk about how to do that correctly.